Hello, so we are back, and this time with a customer job. We have here a nice laptop. This is a HP Victus. So it's an i7, RTX graphics, 144 Hz display. This is a proper gaming machine. Guess what? That's the charger the laptop came in. I mean, on this one, you need probably like a 10-12 amps charger, and you have something like that, like 2 amps charger. It will never work with something like that. But anyway, however, the laptop should charge. Let's say, okay, it's not working on that charger, I understand that. But the laptop should charge when it's off, right? I mean, the charging current probably slower, yeah? Probably under 2 amps. So I have my charger, which is about 3 point something amps. Plug in the charger and I cannot see any light there. You can see no light. What the customer is saying, fails power on from mains. It does power on when battery plugged in until the battery discharged. So looks like the laptop is working on the battery, but not on the charger. Of course, on that charger it will never work. Oh, that's the power button. Pressing the power button, nothing happened. Okay, so let's try to fix this. This is a nice one. Clearly, with that charger, it will never work. But should charge the battery, at least should charge the battery. Okay, let's take the screws out. And we are looking for an input circuit fault, yeah? Input circuit means charging port, the first two MOSFETs, something like that. There should be a fault, just based on what the customer is saying. He's saying when the battery is working. So we can have a dead MOSFET. We can have a faulty charging port. But the charging port is looking good. I mean, you can spot like a destroyed charging port. Oh wait, he's saying the charger? 1 second. Yeah, 10.3 amps. 10.3? Let me check. Yes, 10.3 amps. That's what this laptop needs. And this one has probably around 2 amps, something like that. Okay, we took the screws out. Let's open the laptop. Plastic clips. Okay. So the laptop is open. Now look at this gaming laptop. Never have before a HP Victus. Never heard about this. Proper nice. You have two M2 drives with a heatsink, proper copper heatsink. See, nice. Nice. Okay, let's unplug the battery. How we can access? Look, the BIOS chip here. Easy accessible. So we have the charging port here. Look at this charging port. Has 3 or 6 wires plus 6 wire minus. No, this charging port is fine. Then what we have here, let's take out the M2 drive. Maybe we can see something there. Oh, this is just a it's just the heatsink, but the plus, you can see the big plus track is going on the other side probably. Probably. No, nothing here. So I believe we have to take the board out, which kind of sucks because I was hoping everything to be here. But yeah, let's take the board out. Okay, so the heatsink is out. Nice. As expected. Let's check the main power rail just to be sure it's not shorted, yeah? Just to be sure the main power rail is not shorted. So what do we have here? We have the capacitors. No, nothing. What about this? No, nothing. What about here? No, nothing. No short. So the main power rail is not shorted. Good. That's good. At least we know we have a good CPU, a good GPU. Okay, so we took the board out. And the board is looking quite good. We can see here we have few MOSFETs. So plus is coming here. We have two MOSFETs in the parallel mode there. Interesting design. So two MOSFETs in parallel, then it's going to one MOSFET. So I believe it's more pressure on the first MOSFET. Yeah, two MOSFETs on the parallel, so this is plus. And those are good, are not shorted. And this is not shorted. And they have a diode, check it. I believe this, someone replaced this diode. You can see it's weird, it's strange. Someone replaced this diode. Okay, let's go with the power supply. Let's lower the voltage. Let's see what we have here. Everything is fine. Okay. On the charging port we are fine, no short. On the main power rail is no short. Okay, so we are fine. Let's connect the charger. Let me grab the charging port. Okay, so the charging port, it is plugged in. The charging port is plugged in. Let's plug the charger into the charging port, which we did. And now let's check some voltages, yeah? Like here. Volts. Now let's see what we have on the input. Here we have Here we have 19.4, you can see. Wait, 12, 19. No, 19.4, we have 19.4 here. On the output of the two MOSFETs, we have 0.2. Okay, so everything started going bad from here. Yeah, the output of those two MOSFETs here, 0.3 volts, you can see. I should have 19. Okay, on the gate, we have 0.2. Okay. Now let's pay attention where we are going next. Next we are going to our power management chip. Okay, so we have to find on this board the power management chip. Can be next to the battery. Let's see. It is. Look here. Look my power management chip where it is. Next to the battery connector. Wow. Okay, that's good. Now let's check a few things. Okay, now let's check a few things regarding this power management chip. So what is important? Yeah, we check the MOSFETs, so the MOSFETs are okay, there is no voltage on the gates. The next what we're checking the BQ chip. If has voltage, yeah? Keep in mind the BQ chip is taking power exactly from the charging port, yeah? Not after the MOSFETs. So the BQ chip should have voltage. Not sure which pin. We can see here some capacitor, 0 volts, 0 volts. We should have somewhere a double diode. It's nice. Let's have a look online for this chip, yeah? Give me 1 second. Okay, I found it, yeah? So it's this one. So it's taking power, you can see, it's taking power exactly from the input. Anyway, the reality is different. Also, it's taking power using a diode exactly from the charging port. But this schematic is only from the battery. Sorry, it's taking power from the battery, and here it's taking only from the charging port. So pin number 26, 28, 28. Let's check the pin number 28. Pin number 28. Lol is the last pin. I was counting every pin, so we have 0 volts. You can see the charger is plugged. Oh, the charger is not plugged in. Okay, sorry, my fault. So the charger is plugged in. Let's check the voltage. Pin number 28 is the last pin. We do have 19 volts on the pin 28. Wait, what? The main power rail is not present. No, it's not. It's not present. Okay, pin number 28. Then we have the gates, pin number 4. And we have 0.2. We don't have voltage. Then pin number 6, AC detect. We have like 2.5 volts. Should be right. You know what? I have a chip here. Let's replace this chip quickly, yeah? Because looks like this chip is dead. Yeah, let's replace this chip quickly. I mean, that should be quick. A little bit of flux, a little bit of a new chip, and yeah. Okay, unplug the charger. We need a small nozzle. Small nozzle. Yeah, like this one. Yeah, that should be fine. Around 440 degrees, 50% air. Too much air, yeah. 40% air, better. You know what? I changed my mind. 480 degrees. It's taking too long. Come on. This is a gaming motherboard. It's sucking the heat. That's the problem. Look, 500 degrees and it's not even moving. Okay, let's raise the 45% air. I mean, come on. Oh, this is crazy. Come on. I mean, I think it's something wrong with this chip. Why I cannot take the chip out? The solder is melted, you can see. Lol, weird. I swear it's weird. Proper weird. I mean, what was that? Okay, let me grab a new chip, which I'm sure I have it here. Let me check. No, it's not this one. This one? No, it's not this one. This one? Yeah, this one. This one. Okay, let's solder this chip back. No, this board is sucking the heat. Okay. Okay, so we soldered the chip. Oh, what the hell? Come on, I can't believe we soldered the chip wrong. I can't believe. I can't believe. How you can solder a chip wrong? How you can do it? I'm the only one. I'm the only one which is doing something like that. Yeah, I should get a bigger nozzle. You know, leave a comment and tell me if you are doing something like that or I'm the only one. Huh? I mean, how you can solder a chip wrong? Perfect, yeah? No flux soldering. Okay, let's cool down the chip. Let's cool down the chip. Yeah, still hot. Still hot because this board is sucking the heat badly. It's a gaming motherboard. Okay, let's plug the charger. Should be fine. Let's plug the charger. And we don't have light. Main power rail present. Look on the screen. Look at the multimeter. Power rail 19.4. You can see. So the main power rail is present. And I have light on the charging port where you can't see it. You can't see it. Light there, you can see on the charging port, you have the white light. Yeah, it's not orange because we don't have the battery. You see, this is a nice fault to be fixed on a Thursday evening around like 6:30. That's a nice fault. Okay, now let's put all back together. Let's put all back together and test to see if it's charging, if it's coming on. I'm not sure if I can manage to bring the laptop working with this charger, with my charger. But we can try to use the power supply to supply more amps, more power, yeah? But check here, check here. Yeah, I swear only HP and Apple can do something like that, yeah? So that's the connector from this speaker, and you have to push it on the down, yeah? And this is the connector from the other speaker, yeah? And you have to plug it in. I mean, what's the point? You have two speakers. Why you will use different connectors? Only HP and Apple. Okay, let's test the charging before we are moving forward, yeah? Let's see if it's charging. Plug in the battery. Plug in the charger. And we do have orange light. Check there. Check there on the charger. We have orange light. Let's see the voltage on the battery. The voltage on the battery is going up. 12.1929357. Look, you see how quickly it's charging. Perfect, perfect. So the battery is charging fine. Let's put all back together. Okay, so the laptop is all back together. Let's plug the battery. Let's plug the charger, then let's try to power on. Power on, and the laptop is coming on. Not sure what will happen because it will take a lot of current. Let me check to see what will happen with this charger. We have 19, 18, 18.9 we have on the charger. It's still holding. You remember the HP charger, we fixed it. Was a faulty one. Let's pay attention on the current. 18.7. What message do we have? Wait, this is no Windows? 1 second. Let me pay attention on the voltage. 18.8 volts. 18.8. It's still holding. 18.2 volts. It's still holding. And I bet this is taking probably like 4 amps right now. Okay. Has the charging sign there. Is disconnecting. Is disconnecting and reconnecting. Yeah, you can see. Let's come with some current. Yeah, with some amps. Yeah, it's disconnecting. Yeah. Told you need a lot of current here. So you have minus and you have plus. Yeah, so now we are supplying power next to the charger. Check on the power supply, 5 amps. You can see. So it's charging fine. We have the charging sign. It's taking 5 amps from my power supply. So yeah, you need a solid charger with this laptop. Okay? But we fix it. That's what is important. Let me shut down the laptop. Shut down. Okay? All good. So have in mind, if you have the laptop, yeah, you check the main power rail is not shorted, but you don't have 19 volts. On the gate of the MOSFET, you should have around 25, 26 volts. And I seen on the last video, people ask, sorry, but how is it possible to be 25, 26 if the chip is getting power by 19, but the chip has an inverter inside? You know, an inverter to raise the voltage? Yeah. Okay. So if you don't have that 25, 26 on the gate, check the BQ chip. Yeah. The BQ chip are the power management chip, and the schematic is quite simple of this chip. Okay. I mean, basically, do exactly like what I did. You know, you check. You have voltage on the chip. You have. We had 19. Well, if we have 19, let's replace the chip, because that's the shortest way. I mean, usually, yeah, the chip is dead. So I will say thank you for watching. Like and subscribe if you like the video, and see you on the next one. Bye.